Welcome in the fourth example of variation of a parameter. So this is the example 4 that we have. Okay, so example 4. The question is a d square plus 2d plus 1 of y is equal to e raised to minus x log x. Okay, so first of all, the auxiliary equation is a d square plus 2d plus 1 is equal to 0. So minus 1 is a repeated root. So we get c1 plus c2x e raised to minus x. That is a yc. c1 plus c2x is the yc. That is a cf. Okay, so if we compare it with c1y1 plus c2y2, so we get y1 is equal to e raised to minus x, y2 is equal to x e raised to minus x. So the value of the Wronskian w, which is a y1, y2, then y1 dash and y2 dash, that determinant, if you evaluate the Wronskian value, you will get e raised to minus 2x. You should evaluate the determinant and you will come to know that you will get e raised to minus 2x. You can observe this is a cross multiplication. E raised to minus x into e raised to minus x become minus e raised to minus 2x because the base is same, so the addition of indices. Okay, minus actually this minus sign is written first, so e raised to minus 2x, and that is a okay. You can see the calculation there. Okay, so value of Wronskian is e raised to minus 2x. If there is a correction, you can tell me. So that about, then you have y1, sorry, not y1, this is the u1. U1 is equal to integration minus y2 of fx upon w. Okay, so this minus y2, so y2 is obviously, this is x e raised to minus x, this minus y2, this minus is outside, and this is fx on that is function on the RHS, which is a e raised to minus x into log x upon Wronskian w. So here we have to integrate x log x, and obviously the by parts integration by parts is used, Light rule. Log is the first and x is the second function, and you will get u1 as this one. This is the u1, and don't write that plus c1. So that about the value of u1. We have to see the calculation of u2 also. So let me come to the next page. Sorry. Okay, so this is the last part of that. So we seen already the u1 value of u1. This is the u2. U2 is equal to integration of y1 fx. This is actually y1 fx upon w. So that y1 is e raised to minus x only. Fx is the e raised to minus x log x, and upon w is e raised to minus 2x. So one of the that e raised to minus x entirely gets cancelled. We come across integration of log x. So log x into x minus 1, that's the integration. You should know the formula, and that C2 is not required. And at the end, that yc plus yp written as a complete solution. So that about the example 4. Yes, today I'm not given the handwritten example. Yes, next time I will try to give the handwritten only, because yes, this creates a little bit problem. Okay, thank you for the variation of parameter. Now you are going to get, remember, this Friday, Saturday, Saturday and Sunday, entire days for the practice of variation of parameter. So practice all the examples that we have in the handout. Repeat it again and again, because same type of integration formulas you will require again and again. I already told, whenever sec function is on the RHS, you require particular type of integration. Cosec is on the RHS, tan is on the RHS, or lastly function of e raised to x on the RHS. So that are about some few things that you should keep in mind, and practice that example. Example will come from that only. Okay, that is for 5 marks. Okay, thank you. We'll stop here. Yes, this one is the eighth method. Uh, Method of undetermined coefficient. Already we discussed, this is the optional method for the examples of the type 1 to type 6. That means if the RHS is we say exponential, trigonometric, hyperbolic, algebraic, or e raised to x into v or x into v form, then we can use method of undetermined coefficient. But I suggest you should use the shortcut methods, whatever we learned 1 to 6, because in some of the cases these examples becomes very complicated in differentiation. Let me see a few examples today. So the first example I am taken here. Let I select this one. The example is a d square plus 1 of y is equal to 2x square plus 3 into e raised to minus x. If you observe the RHS, the first one is the algebraic function, second is exponential function. So if we have to go by shortcut methods, we have to use algebraic method for 2x square, and we have to use exponential method for 3 times e raised to minus x. Here the step 1 is common, nothing new is there. So just we calculated yc by the auxiliary equation, as the roots are plus or minus iota. Yc is a c1 cos x plus c2 sin x. So that is about yc. This is the complementary function. Always remember, if the one of the term, if any of the term of the RHS is a part of this YC, if that is a part of YC, in such a case, we have to multiply by x in the YP. That we'll see later on. Right now, let me come to the method of a particular solution. Okay, so this is the very important step, because that only tells us how to get a particular solution by undetermined coefficients. Now we are going to assume, we are going to assume yp, and that assumption is, if x square or x raised to n is there, for x raised to n, c1 x raised to n plus c2 x raised to n minus 1 plus c3 x raised to n minus 2 plus up to some cn. Okay, so like that. So that is the yp that we have to assume, where that c1, c2, c3, cn, that we have to find out. That are some particular constant, and that we have to find out. So if e raised to x is in the RHS, so simply c into e raised to x, that we have to assume that as a yp, where that c we have to calculate it. Now I said here c into e raised to x only. Okay, but in some of the cases we have to take x into c into e raised to x. In that case, that e raised to x, this e raised to x appeared in the here in the yp. We'll see that is in the next example. Right now, that is not a case. So you can see here, as x this 2x square is there. For 2x square, we assume the corresponding yp as, because as the degree is a 2, this x square is there, c1 x square plus c2 x plus c3, we are assume the corresponding yp, and that we have to find out actually. Okay, suppose there is x raised to 4, then we have to take c1 x raised to 4 plus c2 x cube plus c3 x square plus c4x plus c5, like that. Okay, but generally maximum second degree polynomial we come across. So this is the maximum case that we have. Now, and we assume the corresponding yp of e raised to x as a c4 e raised to minus x. Same function you have to keep it. Keep a same function, only this constant that you have to find out. So as we assume, so we are going to replace this y or this yp in the y of the given differential equation. So this is the given differential equation, d square plus 1y of 2x square e raised to minus x. So d square plus 1 as it is. This is the assumed yp that we just here assume. This one is the yp. Just yp replace here, and this is the RHS of the given equation only. Now, what is this first bracket? This first bracket is the second derivative of that yp. This is the second derivative of this yp. That is our first bracket. So you observe, second derivative of c1x square is a 2c1. Second derivative of c2x is a 0. Second derivative of c3 is a 0. Second derivative of c4 e raised to minus x is a plus c4 e raised to minus x. That about a second derivative. Plus, because plus d square of that bracket plus 1. 1 into that bracket. So 1 into bracket, the bracket as it is. So this bracket is as it is of that yp. The RHS is as it is. Now, what is the last step is left here? Just collect the constant together and equate the coefficient. Sorry, collect the similar terms together. So here, c1x square as it is, c2x as it is, these two terms as it is, constants collected together, because there is a 2c1 and plus c3. 2c1 plus c3 is collected. c4 e raised to minus x plus c4 e raised to minus x. So these 2c4 e raised to minus x. and RHS as it is. Now, if we equate both sides, so equating the coefficient of x square, we get c1 equal to 2 because c1 x square and 2x square. So if we equate the coefficient of x square, we get c1 equal to 2. If we equate the coefficient of x, the coefficient of x is not in the RHS, so c2 is a 0. Equating constant term on both sides, we get c3 plus 2c1 is a 0. And equating the coefficient of e raised to minus x, we get this last equation. So when we simplify, we get these values like c1 is a 2, c2 is a 0, c3 is a minus 4, and c4 is a 3 by 2. So when we replace these values, in that assumed yp, this one, okay, this yp, we get here as a particular solution, and then at the end just we return yc plus yp as a complete solution. So yes, it's not so difficult and not so simple also, because this assumption is the most important. Whatever we assume that yp, you should able to assume that yp. At the end of the three example, we are going to sum up how we assume that yp. Okay, so that about your first example. Thank you. Okay, we are in the second example of method of undetermined coefficient, and our example that we have is here is a d2y by dx square minus y is equal to e raised to x plus e raised to minus 2x. So in this case, if you see, the roots of auxiliary equation are plus or minus 1, so our yc is c1 e raised to x plus c2 e raised to minus x. Now here, that important part that we have to observe is if one of the function appears both in yc as well as in the RHS of the given differential equation. In such a case, to write a yp, you have to multiply by x. You can observe e raised to x present on yc as well as in the RHS of the differential equation. So instead of assuming the yp as a c1 e raised to x, we taken c1 x e raised to x. Okay, and the next, that e raised to minus 2x is not present in the yc. So because of that, only c2 e raised to minus 2x is taken. If that e raised to minus 2x is also the part of that yc, in such a case we have to take c2x e raised to minus 2x. So that is only the extra thing that you have to keep in the mind. Otherwise, for e raised to ax, c e raised to ax is the yp, where c we have to determine, that is method of undetermined coefficient. Okay, so these constants we are determining, so the name is given as method of undetermined coefficient. So but whenever that present, we have to multiply by x. So this assumption is the most important part. Once you get that, just we have to replace that yp here, and d square, that's the second derivative, is calculated. Second derivative of this one is calculated here, and that we use. So second derivative of that yp, here is a yp. Okay, so second derivative of yp is taken here. This is the yp as it is, and then e raised to x, terms of e raised to x collected together, terms of e raised to x, e raised to minus 2x collected together. And when we observe that this minus c1x and here plus c1x gets cancelled, only 2c1 left. 2c1 is the coefficient of e raised to x in the LHS, and on the RHS the coefficient of e raised to x is 1. So 2c1 is 1. So c1 is a 1 by 2. c1 is 1 by 2. Similarly, the coefficient, this 4c2 minus c2 is a 3c2, and the coefficient of e raised to minus 2x is also 1. So comparing the coefficient of e raised to x and e raised to minus 2x, we get the values of c1 and c2. And at the end, don't forget to write that yc plus yp as a complete solution. So that about our second example. Important thing is e raised to x, that is a part on both yc and the RHS. Because of that, this x e raised to x taken, but e raised to minus 2x is not a part of here. This is not a part of yc. So only c2. There is no x into e raised to minus 2x that is taken. That's the main thing. Otherwise, the remaining things are same. So that about the second example. Okay, this one is a third example on method of undetermined coefficient. Actually, there are many more varieties of the examples. I'm not covered all that of undetermined coefficient. The reason is, yes, already I told you, better you should do it by the method 1 to 6. At the last moment, you should try this if you are not able to go by the regular way. Okay. So the example we are taken here is d square plus 4 of y is equal to cos 2x. So roots are plus or minus 2i. So the yc we got here as c1 cos 2x plus c2 sin 2x. So again, cos 2x appeared. As cos 2x appeared, so you have to multiply by x for the yp. Okay. So for normal cos ax, suppose RHS is a cos ax, then we take c1 cos ax plus c2 sin ax. That is that we take generally the yp. In this case, as that cos 2x appeared in a yc, because of that we taken x c1 cos 2x plus c2 sin 2x. Okay, so this x we taken because of that. So c1 cos 2x plus c2 sin 2x, this is the yp for a trigonometric function. Suppose RHS is a sin 2x, in that case also the yp will be the same. Okay. If RHS is a sin 2x, then also this is the correct YP, sin 2x for sin 2x. Okay, sin 2x and cos 2x, we have same YP because both cos 2x and sin 2x appeared in the YC. But suppose there is a sin 3x or cos 3x. If we have sin 3x or cos 3x in the RHS, in such a case, the required YP will be only C1 cos 3x plus C2 sin 3x. There will not be x. There will not be x. C1 cos 3x plus C2 sin. That is for cos 3x. So forget about this. Right now we have cos 2x. So this is our YP. So this is the most important thing. Remaining part is only this one. Now we have to just replace this YP in the given equation and second derivative. So one derivative we taken here. Okay, one derivative we finished of that x into product rule. Okay, and then plus 4 into that YP. So 4 into YP is here. Cos 2x as it is. Second derivatives are taken here. Okay, second derivative is taken here, and last this 4 yp as it is cos 2x, then collected the terms of cos 2x, collected the terms of sin 2x, and we observed comparing the coefficient of cos 2x and comparing the coefficient of sin 2x on the both side, we get c1 and c2 replaced here, and we got the final answer. Okay, so this is known as the method of undetermined coefficient. So still, if you have a few doubts, yes, you can ask on the WhatsApp. Mainly, you can keep this method for the option. Okay, so thank you. That about the method. Hello everyone. I am Sachin Vivare, and we are going to start the method number 7 of finding the particular solution of linear differential equation with constant coefficient. So this one is a most important method. This is the most important method, which is a method of variation of parameters. Compulsory, a 5 marks question. One 5 mark question is coming in a final exam. Okay, in a final exam. So, yes, whatever the 5 to 6 examples we have in the handout, if you do that 5 to 6 example and you are able to understand it, yes, you can fix your 5 marks on this method. So, whatever the first 6 method we done, like particular solution of with exponential function, a trigonometric function, hyperbolic function, algebraic function, okay, and then we seen the combination like e raised to ax into v and x into v. So all these 5 to 6 methods that have the weightage of a 5 mark. Okay, this is the only one method which have again a 5 marks weightage. So let me see what is this method. So mainly only we are going to solve the second order differential equation with the help of variation of parameter method. Suppose the differential equation is in the form of a d2y by dx square plus b dy by dx plus cy is equal to fx, where that small abc's are the constant arbitrary constant there. Okay, so step number 1 is a common. The step 1, which is find yc, complementary function, which is a c1y1 plus c2y2. Okay, that is a common. Once we complete the step 1, that is a complementary function, then assume yp is equal to u1y1 plus u2y2, where that u1 and u2 are the unknown function that we have to find it. So for that we have the formula, which first formula is for u1. u1 is equal to integration of minus y to fx upon w dA with respect to x. Okay, capital W is known as a Wronskian, and that Wronskian is given here. That capital W is equal to determinant of y1 y2 and y1 dash y2 dash. Similarly, the formula for u2 that we have is a integration of y1 fx upon w dx. Okay, so that about the theory. It's again a formula oriented. Once you remember the formula, yes, we can use it to get a required solution. Okay, so that about the theory. Welcome, welcome in the first example of variation of a parameter. The first example that we have is d2y by dx square plus y is equal to tan x. Okay, so step 1, that is a yc. Auxiliary equation is a d square plus 1 equal to 0, so root r plus or minus r. So yc is a c1 cos x plus c2 sin x. So we are going to assume that as a c1 y1 plus c2 y2. Yes, here we completed the step 1, but yes, the remaining part, this one, we are going to do it for getting the yp of a calculation of variation. Two, three important things. When this method we are going to use it in the exam, yes, you will have the separate question on calculus of a variation of parameter method. So the question is strictly written as find the solution of this one by variation of parameter method, so you have to use it. And another way to identify if it is not given, okay, that is generally not happen, but if suppose not given, then the way to identify is the RHS is either tan x, sec x, cosec x, or function of e raised to x. Means it is not like e raised to 2x, it will be like a, log of e raised to x, something like that. Okay, so tan, sec, cosec, or function of e raised to x, then the example can be done only by variation of parameter method. Okay, so that is the way to identify. And remember, this is the important method. It have a compulsory 5 marks question in the final exam. So if we compare, now let me come to the example. So this is your yc is a c1 y1 plus c2 y2. If we compare it with y1 become cos x, y2 becomes a sin x. So first we calculate the value of Wronskian is a w, which is a determinant of y1 y2 upon and y1 dash y2 dash. So y1 is cos x, y2 sin x, y1 dash derivative of cos x is minus sin x, derivative of sin x is cos x. Now if you find the determinant, it becomes cos square x plus sin square x, so w value is 1. So let me find now the yp. We'll start step 2. Step 2 yp. The formula for yp is a u1 y1 plus u2 y2, where the formula for u1 is integration minus y2 of fx upon w dx. Okay, so here the value of y2 is replaced as a sin x. Okay, fx is a tan x and w is 1. And just the integration is important. One more problem to many of the student is the integration. They are not able to integrate. But few methods that you have to remember, because already we've seen this method mainly comes in the RHS tan x, sec x, cosec x, and function of e raised to x. So only that one example of each if you completed, yes, you can do any of the example then. Okay, so this is the example of tan x. You should complete one example for sec x, one for cosec x, and one is for function of e raised to x. Okay, so in this case, this is the integration that we have to do it. So sine square is converted as 1 minus cos square x upon cos x. Now the separate division is done. Like cos square upon cos is a cos x, and 1 upon cos is a sec x. This minus sign mainly changes the position of them. Okay, and now integration of cos x is a sin x, and integration of sec x is a log of sec x plus tan x. Okay, so that about u1. We got u1. Now this side. Okay, this side you will find the calculation of u2. u2 is equal to integration y1 fx upon w dx. So u2 is equal to integration of cos x into tan x dx. Okay, and integration of so simplification, because tan is a sin by cos, cos get cancelled. We left integration of sin x into minus cos x. So at the end, yes, yp is u1 y1 plus u2 y2, and that simplification gives you, because this first term and this last term gets cancelled, and you're left with that as a yp. And at the end, this is a yc plus yp is the complete solution. So that about your first example. Okay, so thank you. Hello everyone. I am Sachin Vevare. Let me see few more examples on variation of parameter method. Already I told this one is one of the important method because compulsory the 5 mark example is coming in the final exam. Okay, so definitely the practice is required for this method so that you can fix your 5 marks. Yes, few examples we are going to see which are from the book only. So and few corrections are there in the that book only. So there is a calculation error. We'll see that one by one. So first of all, the example that we are taken here is d square plus n square of y is equal to sec nx. So step number one, the auxiliary equation d square plus n square we are equated to the 0 and we are getting d is equal to plus or minus in as the root. So the yc we get yc as a c1 cos nx, c1 cos nx plus C2 sin nx. So if we compare this with C1 y1 plus C2 y2, so y1 is a cos nx. So I will say this is a y1 is a cos nx and y2 as a sin nx. Okay, so you get y1 and y2 as cos nx and sin nx. Next step that we have to calculate the value of Wronskian, that is a w. W is equal to, yes, we have the formula y1 y2 y1 dash y2 dash, that's a determinant of that. So if you evaluate that determinant, so Wronskian value you'll observe that will come as n only. Okay, so in this case we have n as the Wronskian value. Next, yes, yp, we take yp as a u1 y1 plus u2 y2. So that is our formula. So this is right now our u1 is equal to integration of minus y2 fx, that is y2 fx upon capital W. Okay, so this is a change, y2 fx. So in this case, this is the minus sign is outside, minus integral of y2 is a sin nx, fx is a sec nx. This is the value of Wronskian W. Okay. Now the integration. So for that, minus 1 by n is taken outside and we come across integration of tan nx. So integration of tan nx is a log of sec nx. So here there is a printing mistake. Actually, there should be a bracket and that should be integration of tan nx is log of sec nx upon n, that n into n become n square. Okay, so minus 1 by n square log of sec nx. So you can keep this as a u1, no need to simplify, or if you want in cos nx, we should know that log of sec nx is equal to minus log of cos nx. So this is also the correct u1. You can keep either minus 1 by n square log of sec nx or plus 1 by n square log of cos nx. Don't write plus c1. Actually, this is not required. Okay, so in u1 and u2, will not take a constant of integration. So that is again the wrong thing done in the book here. So next we are calculating u2. Already we've seen if u1 is a lengthy, u2 is a simple. Now you can observe the calculation of u2 is a simple. So formula for u2 is y1 fx integration of this is a y1 fx upon w dx. So y1 is a cos nx, fx is a sec nx, and Wronskian is a n. So sec is 1 upon cos, so gets cancelled. We are left with integration of 1 by n only. So the integration will come x by n. So integration of 1 by n is x by n. Again, the constant of integration is not required. So once we get that u1 and u2, we are replacing here, that is u1 y1 plus u2 y2, and that becomes our yp. So here the yp is a written. So actually this constants not required, x should be there, and that is the correct thing. Okay, so at the end that yc plus yp is the complete solution, and I think this is the correct, nowhere is a mistake there. So that about your the example 1 for calculus of variation. One more example that we have here is d square plus 1 of y is equal to cosec x. It's similar to this only. You can see the change. Instead of d square plus n square, the value of n is coming 1. Instead of sec nx, there is a cosec x. So I will say this example is for your self-study. You should go through it and you should complete it your own. Okay, so thank you for that first example. We'll see one more example. Okay, after this. Welcome in the second example of variation of parameter method. So the example we are taken is d2y by dx square minus y is equal to 2 upon 1 plus e raised to x. So this is a case where you have function of e raised to x. So RHS is some function of e raised to x, and in such a case also generally the variation of parameter comes. So don't worry about too much about identification, because in the exam you will be given find the solution by variation of parameter. Okay, so in this case the auxiliary equation is a d square minus 1 equal to 0, roots are plus or minus 1, and we have the yc as a c1 e raised to x plus c2 e raised to minus x. So when we compare it with c1 y1 plus c2 y2, we get y1 as a e raised to x, y2 as a e raised to minus x. So the Wronskian, that is a determinant, okay, determinant y1 y2 y1 dash y2 dash becomes minus 2. The value of Wronskian is a minus 2. So that about step 1. Now let me come in the step 2. Okay, so for step 2, just a minute. So this is the step 2. We have u1 y1 plus u2 y2 as a yp. So u1 is equal to integration of minus y2 fx upon w dx. So the value of y2 is e raised to minus x. This is the f of x, and this is the value of w. Okay, so the simplification, minus minus become plus. This e raised to minus x is taken in the denominator with the e raised to plus x. Now, yes, the integration is a difficult task for many of you. Now, to integrate this, yes, we are arranging the derivative of e raised to x in the numerator. So, just we are added e raised to x in the numerator, and denominator is taken as a e raised to x bracket square. So, if we put e raised to x is equal to t, then that e raised to x dx becomes dt. Okay, e raised to x dx is a dt, and denominator comes t square into 1 plus t. So to integrate this, obviously the factors in the denominator, so partial fraction a upon 1 plus t plus b by t plus c by t square. This is the partial fraction for linear factor and the repeated factor as a t. So we have to find out the values of capital ABC. Yes, you can find these values of capital ABC in inner of, okay, of partial fraction. I written directly the value of a will come 1, value of b is coming minus 1, and the value of c is coming plus 1. So this is 1 upon 1 plus t minus 1 by t plus 1 by t square dt. So integration of 1 upon 1 plus t is a log of 1 plus t, 1 by t integration is a log t, and 1 by t square integration is minus 1 by t. Okay, so this is the integration of these three terms. So little simplification is done. Yes, generally it is expected from you. Log a minus log b is written as a log of a upon b. Okay, replace the value of t, that is e raised to x. Then separate division. If you take a separate division, 1 upon this 1 upon e raised to x is a e raised to minus x, and e raised to x is 1. Okay, so that about log of 1 plus e raised to minus x, and 1 upon e raised to x is again e raised to minus x. So that about u1. Always in variation of parameter, when you find out u1 and u2, one of the u1 will be always difficult, and one of the value of means either u1 or u2 is a one of that is a simple for calculation, and another comes a simple calculation. For example, in this case, you observe that u1 is a lengthy, this part is a lengthy, but the part of u2 is a simple. You can observe this u2 integration is simple. So that always happen. One of the integration is simple, and one of the integration becomes little difficult. So y1 value is replaced. This is the value of w. This is f of x. Simplification, similar thing. E raised to x is equal to t gives us dt upon 1 plus t. So integration. This is the value of u2. So then u1 y1 plus u2 y2 is written, and it is little bit simplified, and you got that at the end, then yc plus yp as a complete solution. It is little lengthy example, but yes, not so difficult. Practice is required, and definitely you can do it. Okay, so thank you for watching the second example. So we'll take few more example, maybe 2 or 3 tomorrow, because this is the important method. So we'll take some extra example. Thank you.